Hi everyone! In this video we'll continue our work for exercise 10. We're going to do some slightly different examples beyond just the simple sine and cos graphs. So in this case we're going to be looking at the case where we have a cos graph or a sine graph, but we've got something before, for example there, y equals a sine theta or b sine theta or b cos theta. Okay, so this is the example we're going to be looking at in this video. So the instructions are the same again. We're going to sketch these two graphs between theta equals 0 and theta equals 360, and then we're going to try and interpret them. So they look a little bit different at first because we've got a half sine theta and minus 3 cos theta. But we do the same steps as always. So we start out, we have our table, and we work out some points. So we plug in the values of theta into y half sine theta. So if we have y equals a half sine theta and we plug in 0 as our theta value, we get 0 again. If we plug in 90, we get a half. If we plug in 180, we get 0. Sorry. 270, we get minus a half. And 360, we get 0 again. We do the same thing with the cos graph, so we plug in values of theta into y equals minus 3 cos theta. For 0 theta, we get minus 3. For 90, we get 0. For 180, we get 3. 270, we get 0. And 360, we get minus 3. Okay, so those are the values that we plugged in. We've got our points now. What we're going to do is we're going to start plotting the points on the graph so that we can draw it. And remember, we use a smooth curve, not straight lines for these graphs. So if we look at the y equals a half sine theta, we're going to plot it using red points. So we have a point at 0, then we've got one at half, so that's quite low there. At 180 degrees, we've got at 0 again. At 270, we've got a half, so that's quite small there. And 360, we've got 0. Okay, so we draw our graph with the smooth curve. And that's the shape that we get for the sine graph. For the cos graph then, we use the points, so we start at minus 3, go up to 0 at 90, 3, 270 is 0 again, and 360 we've got a 3. Once again, we fill in the curve using a curved, smooth curve. Okay, so those are the graphs that we get. So before we start interpreting these graphs, I just wanted to quickly compare them to the graphs that we got in the last video. So in the last video, we've got the graphs that are at the bottom, so the graph of y equals sine theta and the graph of y equals cos theta. So if we compare the effect that that number in front of the sine theta and the cos theta have, we can see that for y equals a half theta, it's got a much smaller amplitude. So basically, the amplitude halves when you put a half in front of the sine theta, which is why we've got a much smaller graph in the top graph compared to the lower graph. For the cos theta, we have a minus 3 in front of it. And actually, if you look at it, it's actually just flipped upside down completely. And the amplitude's increased a lot. So the amplitude has increased from 1 to 3. As you can see in here, that's the amplitude, so that's going to be 3 now. And obviously, the graph has flipped upside down. So that's quite an important thing to note. When you place a number in front of the function, for example, you have y equals a, which is a number, cos theta, that a actually affects the amplitude. Okay, so now we can start interpreting the graphs. So if we look at y equals minus 3 cos theta, the domain is still said to be from 0 to 360. So even though we put a minus 3 in front of the cos, it doesn't affect the domain. So for domain, we still have x as an element of 0 to 360. Okay, now the range is from the lowest y point to the highest y point. So for cos theta, the graph, we've got from minus 3 down here at the bottom all the way up to plus 3. So that's our new range. So y is an element of minus 3 to 3. So although it doesn't change the domain to have a minus 3 in front, it does change the range. The max, as we've identified, is y equals 3. The minimum is y equals minus 3. And now the amplitude, again, we always work with the amplitude from the x-axis up until the maximum point, and it's that height. So we have the height of 3 there. So our amplitude is 3. Once again, we can see y equals minus 3 cos theta. The minus 3 changes the amplitude. Because it's a height, it's not negative, so we always use positive 3. So that's our amplitude. And the period, once again, we range from, we've got half of a trough here, so that makes a full trough, and we've got a full crest here. So in the end, we have one full complete wavelength here, which means that our period is from 0 to 360, so it is 360 degrees for our period. Next, we can look at the components of y equals a half sine theta. So as given in the question, the domain ranges from 0 to 360, so it stays exactly the same for this question. The range is what's going to change. So if we look at the range here, we look at the highest y value, the greatest y value, which is at a half here, and the smallest y value, the minimum y value, which is at minus a half. So if we write that in, our max is y equals a half, our min is y equals a minus a half. Okay, so that means our range for the y values is from minus a half to a half. Okay, so once again we are seeing that the half in front of the sine theta, it changes the range, it changes the y values, but it has no effects on the domain. Let's look at the amplitude next. So the amplitude, as we said before, is this height here from the x-axis until the maximum height. Okay, so in this case, the amplitude is equal to a half. Okay, so once again we see that by changing the value in front of the sine theta, we change the amplitude. Looking at the period, we've got one full crest here, one full trough here, so the full wavelength runs to 360, so our period remains 360. So just as a summary, in this question, we've looked at two different graphs. They've got different values in front of the cos or the sine function, and basically the effect of that is the value in front, so this y equals a sine theta. The a is actually your amplitude, which is quite a useful thing to remember. If you have any questions, please let me know.